All right, guys, we're on the back side of notes, and we're going to look at 7 and 8. They're very similar to what we were doing on the front. However, they're multiple choice questions. Okay, so here's my line of thinking. Why solve these the correct way and then have to check our answers or our solutions in the end when we could just plug in our choices and skip all the solving by hand? Do you know what I'm saying? I hope that makes sense to you guys. All right, so because we have to plug in anyways to see if our solutions stay or go, and we have solutions right in front of our faces in our choices, might as well just check them since we have to check them anyways. So with multiple choice, we can skip all the algebra work, all right, and go right to our solutions and check them. So I'm going to go ahead and check -8. So my b's are going to become -8. So there's my left-hand side. And my right-hand side will become 2 times -8 squared minus 64. Okay, so the left-hand side stays -8. Right-hand side goes into my calculator just like I wrote it. And when I plug in -8 and I check this side, it comes out to be 8. And that's not equal, which means choice 1, okay, and choice 3, because there's a -8 in choice 3, neither one of those can be my solution. So I'm down to a 50-50 just by plugging in one number. So now I'm going to go ahead and check 8. So my left-hand side of my equation, that b becomes an 8, equal to the right-hand side, which is 2 times 8 squared minus 64. And I type that right in my calculator. Okay, left side stays 8, and right side is also 8. And so this one checks. And therefore, choice 2 is my answer. Okay, now if 8 rejected, this is called the empty set because there's nothing in it. Meaning that if -8 didn't work and +8 didn't work, then I would pick choice 4, which is my empty set, which means no solutions. Okay. All right, let's go ahead and look at number 8, and we're going to do it the same exact way. Okay. So again, we're going to, because it's multiple choice and we have to check our answers anyways, we have answers right in front of us. Might as well just check them to see if they work. So let's go ahead and try 5. And so all my x's will become 5. So on my left-hand side, we have 5 squared minus 4 times 5 minus 5. Okay. And we're going to see if that's equal to 2 times 5 minus 10. All right, so all my x's became 5, and we're going to see if 5 works. If I type in the left-hand side, I end up with 0. Equal to, if I type in the right-hand side, I also end up with 0. And therefore, 5 is a solution. So what that tells me is that choice 1 has to stay, choice 3 has to stay, and choice 4 has to stay. But choice 2, there's no 5 in there, and therefore, since 5 is a solution and choice 2 doesn't have 5, choice 2 is gone. Okay, so I'm going to go ahead and I'm going to go to choice 3 now, and I'm going to go ahead and check 7. All right, so square root, x's become 7's now. And in my calculator, I can really just go up, grab what I just typed in, change all the 5's to 7's, so I don't have to retype the entire thing. And when I hit enter, the left side gives me 4. Okay, I'm going to go ahead and type in the right-hand side, or change the 5's to 7's on the right-hand side and hit enter, and you end up with 4 as well. And so 4 is a solution. Well, I'm sorry, not 4 is a solution. 7 is a solution because that's what I typed in here. All right, so that means to me that I have to keep choice 3 and I have to keep choice 4 there, which if I use some logic, I probably didn't even have to check 7. Well, I guess you did, because then choice 1 still works, which means choice 1 is gone because it doesn't contain a solution of 7. All right, so let's go back. And we have one last solution there to check to see if it is. And so we're going to go ahead and check it. Plugging in 3 this time for all my x's. Left-hand side, okay, when I type 3 in, something weird happens. It gives me an error. And the reason why it gives me an error is if you take a look at what's underneath here, that would be a 9 minus a 12 minus a 5. Okay? If you think about what 9 minus 12 minus 5 is, okay, and that gives you a -8. And the square root of a -8, you can't do. That's what something called non-real, okay? It's okay to have a negative number underneath an odd root, but this is an even root because it's a square root. And so this is going to be non-real. And we'll start talking about those in a little bit. Okay, so I'm really sure that this isn't going to work out, even if the other side gives me an error, which it's not going to. When you think about it, that's really 6 minus 10, which is -4. Okay, and so we're going to say that this does not work out, and so 3 cannot be a solution, and therefore we're going to stick with choice 3. Okay, where 5 and 7 both plugged in, the left side equals the right side, so then we know that those are solutions. Okay. All right, let's take a look down here. Number 9 says, consider the system of equations shown below. Part A asked me to solve this system algebraically. All right, so we just did algebraically in the beginning of our unit here in day 2, and we know that we're going to use some substitution. So we're going to take this x plus 1, it's what y equals, and we're going to drag it up here and replace that y. Or we could have took the square root of x plus 3, circled that, and put it in for the y in the second equation. Doesn't matter. Either way, you're going to end up with x plus 1 equaling the square root of x plus 3. Okay, and so on the front side, we know that we have to go ahead. This is already isolated, and we have to square it to get rid of the square root so that we just get the x plus 3 drop down. And we know that we have to write it out twice because it's squared and put it together with our double distribution. So we're going to end up with x squared. That's going to be a 1x. That's going to be a 1x, which is 2x. And that is going to be 1 times 1, which is 1. Okay. We're going to go ahead and subtract x. We're going to go ahead and subtract 3. And we know that we have to do that because we need to be equal to 0 because we have a squared term, which is going to give us 2 answers. Okay, nice easy trinomial. Hopefully it's factorable, so we're going to multiply to -2 and we're going to add to 1. Numbers that multiply to 2 are only 2 and 1, and to get a positive 1, that's going to have to be negative. So if I multiply them, I get my -2. If I add 2 and -1, I get my positive 1. And so now I can go ahead and factor my easy trinomial into x plus 2 and x minus 1, and we're equal to 0. All right, we're going to turn our factors into solutions, and so we end up with x equals -2 and x equals positive 1. But if you recall, this is a system of equations, and systems of equations need to be solved for all variables. So we're going to go back up and we're going to grab the linear equation, which is y equals x plus 1. And we're going to go ahead and plug in our x values so that we can get our y values. Okay? And so here we go. So that's going to be -2 plus 1, which is -1. And now we have a point of intersection, which is -2, comma, -1. On our other side, we would have an x value get replaced, okay, with 1, and 1 plus 1 is 2. And so our point of intersection would be our x value, comma, our y value, and so we end up with the intersection of 1, comma, 2. And so that system is solved, and we are finished. Okay. However, if you remember what we were talking about with radical equations, is that sometimes we end up with solutions that get rejected. And we never did really any checking. And so what we have to do is we have to go back up and we have to check. So we're going to go ahead and grab the first equation, okay, which is y equals square root of x plus 3. And we're going to check each one of our solutions into it. Okay, so if we're checking our first solution, the y becomes the -1. And we have the square root of our x value, which is -2 plus 3. Okay. -2 plus 3 is positive 1, and the square root of positive 1 is 1. And what we're going to realize is that this actually doesn't check. And so this whole solution gets rejected. Okay. Now we're going to go ahead and check our other one. So we're going to use the same equation, y equals square root of x plus 3. And we're going to check this solution now. So our y value is 2. And our x value is 1. And left side stays 2. Right side, 1 plus 3 is 4. And the square root of 4 is 2. This one checks out. And so this answer is the only one that can stay, which means we do not have 2 points of intersection. We actually only have 1. And so we're going to go ahead and graph the system so that we can see what that one solution or intersection point looks like. Okay. So if we go ahead and we type in our calculator, okay, under y equals the square root of x plus 3. And in y2, we can type in our second equation, which is y equals x plus 1. we can get some points if we look at our table. And we don't have any axes on our graphs, so we're going to have to check out our points to see if we have to move our axes or if we could just draw them right down the center. Okay. And so let's take a look at our table. Okay. For our square root of x plus 3 graph, it looks like -4 has an error, so we don't want to graph there, but we can graph -3, 0, -2, 1. We can graph 1, 2, and looks like 6, 3. Okay. For our second table, which is our linear equation, we can go ahead and graph -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, and we could graph more points, but that might be enough, okay? So I don't think that there's any number that is extremely big or small, so I think our axes are fine right down the middle of our graph here. So I'm going to use this as my y-axis. If I had a straight edge, I'd draw you a nicer, straighter line. And I'm going to use this as my x-axis, okay? So my first graph here is my square root, so I'm going to graph -3, 0, -2, 1, +1, +2, and 1, 2, 3, 4, 5, 6, 1, 2, 3. And 1, 2, 3, 4, 5, 6. Yep, that's in the right spot. Okay. If you go to your graph, you can see that it continues to go to the right and up. So I'll put an arrow on that side. But if you look at your graph, it does not keep going down. And so now we'll go ahead and graph our second equation, which is our line. Okay. And so we'll go ahead and put a point at -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, and right there is our point of intersection. And if you remember, that is the point that we got, all right? So +1, +2 is where they intersect. So our graphic work matches up with our algebraic work, all right? Pretty cool. And then 2, 3, and I could keep going in this pattern since it is a line, okay? I know I don't have them in my table, but that's all right. All right, nice straight line that keeps going down and to the left and up and to the right. And there is my algebraic and graphic solution of 1, 2. All right, I will see you guys on the next day of notes.